A large number like this, I could just have you focusing on here, please. Not long till we finish. So, large number, maybe even larger numbers. Certainly in engineering, you're talking about big forces on structures and things like that. We can get some very big numbers. And equally, if you, in electricity, charges on electrons and things like that are really small numbers. We talk about capacitances of tiny amounts, picofarads and so on. So we need to be able to express large and small numbers. Engineering notation is the way that we use it. There's also standard form, so we need to look at both, although engineering notation is generally the one we use. So what I do is, I move the decimal point from where it is now, and if it's not quoted, it's always at the end, you know that, it's there. So I move it to somewhere convenient in engineering notation. In standard form, I've got no choice. I move the decimal point to after the first significant figure. So in standard form, I move the decimal point to after the first significant figure, 3.6. And then I say, what have I got to do to get the decimal point from there back to where it should be? Times by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So I put on, I'm going to multiply by 10 times. And that will be written as standard form, 3.6 times 10 to the 10. In engineering notation, the only difference is, so this is standard form, where the decimal point is always, and that's underlined, always after the first significant figure. In engineering notation, similar, but we've got a choice. We can move the decimal point where we like. And what we do is we move it so that the number in the power here is a multiple of 3, because that fits in with the prefixes like mega and kilo and so on. So that's not in engineering notation because it's a 10. So what I do is, okay, I've got to, let's just look up at this bit, because if you get this now, it'll make it easier. That's where it is now. So I've got to move it 10 places to get it back to there. If I move it here, then I've only got 9 to go. And so that makes it 36 times 10 to the 9. Now it's in engineering notation because that power is a multiple of 3. Okay? So this is engineering notation. And the key for that is the power must be a multiple of 3. Using shorthand there to write it, okay? So engineering notation, you've always got the power in multiples of 3. And because the decimal point is not fixed in engineering notations, we've got a choice. It could be any multiple of 3. So I could equally write it as 36,000 times 10 to the 6, yes. And I might want to do that. So that too is in engineering notation. Yeah. Or I could go back another 2 places and call it 0.036 times 10 to the 12, but it's unlikely I would do that. So both of those are in engineering notation. And the reason why we do it is because 36 times 10 to the 9 could be written as 36 giga, whatever unit we're talking about. So 36 times 10 to the 9 joules, if we're talking about energy, will be 36 gigajoules. So we need to know those prefixes, and I will list those probably next week now. Or 36,000 times 10 to the 6 joules would be what? What's a million? Mega joules. And so the reason why we use engineering notation is because you can immediately transfer straight to other units like gigajoules, megajoules, kilojoules, etc. Okay? Go in threes. One more example before we stop. Because I don't want to leave it the story in the middle. That's just how we represent large numbers. What about small numbers? 0.0000036. Exactly the same idea. In standard form, we've got no choice. We've got to move the decimal point to after the first significant figure. And then we ask ourselves to get it back now from where I put it, 3.6, to where it should be. I'm now not multiplying by 10, I'm dividing by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So I'm actually multiplying by the inverse of 10, which is the same as dividing by 10 times. So a minus sign means I'm dividing by 10. So that would be 3.6 times 10 to the minus 10, and that would be in standard form, because it's not a multiple of 3. Thinking about how the decimal point moves around, a question, what would I do with the decimal point to put it in engineering notation?
Would you put it over 3?
So what would I write?
0.36 times 10 to the power.
Correct, well done. Well done, okay? Here I've got to go back 10 places to get it to there, so if I move it from there rather, I've got to go back 10 places to get to there. So if I move it to here, I've now only got 9 to go, haven't I? So 10 to the minus 9. And now it's in engineering notation. And similar reasons for why we do that, because 10 to the minus 9, anybody know what that is as a prefix? No, that's the large, giga. Small, pico, 10 to the minus 12, so close. Nano, yeah. So I could write that as 0.36 nanojoules if we're talking about joules. So we'll stop there, okay, and I will just summarize that next week, and then we'll carry on and look at formulae. So